All right, class. Today we're going to be talking about the scientific method. The slides in this presentation start at the bottom of page 5. The first thing I'd like you to do at the bottom of page 5 is we got a little pop quiz for you. I'd like for you to write down what you can remember about the scientific method and the steps that you remember about the scientific method. You can pause this video if you need some more time to write down your steps. The steps that we're going to be taking a look at today are as followed. Here are the steps. Step 1, make an observation. Step 2, gather some background research and ask a question. Step 3, form a hypothesis. Step 4, design an experiment. Step 5, gather and present that data. Step 6, analyze the data, draw some conclusions, and submit for a peer review. We're going to be going through each of these steps today. I'd like to start off by saying, and just add this, that not all of the information that we go through on the slides is going to show up in your packet. So if you want to take some extra notes off to the side, you can do that. All right. So step 1 of the scientific method is to make an observation. When making observations, you can be objective and subjective. When you're objective, those are called observations. So it's an objective fact learned by using your human senses. An inference is a reasonable conclusion based on the observations and evidence that you are observing. Here are some observations and inferences. As they come up on the screen, think to yourself if this is an observation or an inference. There was a parked car next to the dead deer on the side of the road. The car hit the deer. The car was parked 10 meters from the deer. The driver was speeding. What I'd like for you to do next is in the sticky notes right underneath this image in your packet, I'd like for you to record 3 observations and 3 inferences. Pause the video now. Step 2, background and research. What is previously known about the topic? And then you're going to build on that. What is it that still needs to be known or confirmed? Step 3 is important, and this shows up a lot on our AP exam. I haven't seen an exam where they haven't asked for you to write a hypothesis or to pick the best hypothesis. So here are some rules for writing a hypothesis. A hypothesis is written as a statement, not a question. I think or I predict is not found in a hypothesis. A hypothesis should be testable. For a hypothesis to be properly supported through evidence or rejected, it must take a specific stand one way or another, so it can't be wishy-washy. You have to pick a side. Read these hypotheses and determine which rule from the previous slide has been broken. Is this a good hypothesis? We went through these scientific method terms in class. Here are the answers, just in case I did not get a chance to talk with you or your partner, or you missed that warm-up in class. What is a null hypothesis? There's nothing in your packet that lines up with this slide, but I'd recommend writing down what a null hypothesis is if you don't already know what a null hypothesis is. So it predicts no relationship between 2 phenomena or no differences among the groups. Some people call it a devil's advocate hypothesis, since usually you're interested in showing some sort of relationship, but not always. And we see this a lot with the tobacco scientist coming up with a null hypothesis that there are no relationships between smoking and maybe an increase in chances of getting lung cancer or other types of cancers. Step 4 is designing your experiment. Okay, when designing your experiment, the most important part is identifying your independent variable, your dependent variable, and your controlled variables and your constants. The independent variable is what will be changed by you, the experimenter. The dependent variable is what will be measured, and the controlled variables or the constants are all the things that are going to stay the same. The more constants you have, the more validity your experiment is going to have. Here's a little device that you can use to help remember the difference between independent and dependent variables. So mix and dry, the first letters in each of these statements stand for something. So M is for manipulate, I is for independent, and the X in mix means that this variable is going to go on the X-axis. And then for dependent variable or dry, D stands for dependent, R stands for responsive, the one that responds to the other variable. And this variable always goes on the Y-axis. Some common issues with experimental design: maybe a small sample size, not repeating trials, uncontrolled variables, no control group, and more than one independent variable. Uh, any one of these issues will bring up some validity issues in your experiment and should be addressed. Read this experiment and see if you could identify the independent variable, dependent variable, control group, experimental group, and at least 3 constants. Step 5, gather and present data. Your data, you can have 2 different types of data. You have qualitative data, which is usually descriptive words like color, smell, texture, the presence of smoke, sounds, things like that, things that you can pick up with your senses. Quantitative data is your numerical data. So maybe you're counting bubbles, measuring length, weight, or just counting something. Always involves numbers. Now, your data can be presented in lots of different ways. Maybe it's a table, a pie chart, a bar graph, a histogram, a line graph, or a scatter plot. There's another scatter plot. Oops, sorry, jumping around here. After you organize your data, you're going to want to analyze your data and draw some conclusions. Here are some things that your conclusion should include. So you're going to want to restate the problem or the question. Was the hypothesis supported, not supported? What did the data say? What was the control group, the independent variable and dependent variable? Describe the graph and any trends that you could pick up on in your data tables or your graphs. Possible causes of error. Was there issues that occurred during your procedure? Identify causes of error. What are some real-world applications of this experiment? What are new questions that have come up as a result of this experiment? What are the suggestions for further research? And then a final summary statement. Some things that should not be included in your conclusion: you should never use I, we, you, or I'm sorry, us, me, my, our, any pronouns anywhere in a lab report. So your lab report should never include pronouns. Here's an example. We conducted this experiment over 4 days should be this experiment was conducted over 4 days. So we got rid of the we. After that, you could potentially submit your research for peer review. If it's accepted, it will then or could be become a scientific theory or an explanation for something. This is only formed if the experiment is repeated many times by many people and the results are always consistent. All right, guys. I hope that was helpful. If you have any questions, let's chat about it in class. Have a great day.